Careful. All right, so today we are starting with quadratics. Why? Because you can hide a quadratic inside a log problem. That's what we're going to be doing. So a typical quadratic, when it's done, when you get it all done, it's going to come out to something like this. X plus 5, x minus 3 equals 0. And then you know the answers are x equals 5 and x equals 3, right? Okay. What? X equals negative 5 and 3. Very good catch. I wasn't trying to catch you, but I did say it wrong, I think. Negative 5 and 3 would be my two answers. All right. Now, here's two complications you have to be able to handle. What if it's like this, but then it doesn't equal 0? What if it equals like 8? Then what do you do? You can subtract it, but first you'd have to multiply the left-hand side all the way out, x squared, and then the outside and the inside would make plus 2x, and then the last would make minus 15, equals 8, and then what would you do? Subtract 8 from both sides. Yeah, you make, so the other side's 0, true. And then it equals 0, and then this thing, what if this thing won't factor then? Sometimes it does, sometimes it doesn't. Minus 23. I think it's right, isn't it? Okay. Then quadratic formula. Do you remember it? Opposite b, and yes, negative b is what we've always said, but I think we should change that to opposite b, because sometimes b is negative, and then people say, well, it's already negative, yay. They'd forget to change it. So you want the opposite of whatever b is, plus or minus the square, root b squared minus 4ac all over 2a. And this one, realistically, you would not be able to do in your head. And you're not going to have calculators on this test, so what do? You leave it with a great big square root and big ugly numbers. Try this one, please. Write this one out. It'll be easy. You just stick the numbers into the quadratic formula. All right, so here we go. Sorry about the coughing fit. X equals negative b, so opposite b, opposite 2, plus or minus the square root of b squared, which is 4, minus 4, and then a and c I like to put in these, except a is really just 1, and c is negative 23. That's where the hardest part is, right there, all over 2a, and the 2a would just be 2. And there we go. So now, there's my answer. But how could this be a log problem? Well, if the problem had originally been something like this, log of x squared, notice I squared the whole thing, not just the x, plus, let's see, outside, inside, so plus 2 log of x, and if I write it that way, minus 15 equals 8. All right, if I write it this way, do you get that that 2 could have been up on the x? This 2 could be up here and be the same exact thing. All right, so that's a typical problem that you're going to be given, and you'll have to notice that, oh, I've got something squared, something that's, well, as soon as I move the 2 down in front, something that's not squared, and then a number. Whenever you have that situation, you have a quadratic. Again, if I had 2 log x minus 3, let's make it plus, otherwise it's going to be ugly, 3 log x, and this part's squared, minus 5, you should be thinking, oh, it's a quadratic, because I got something squared, something that's not squared, and then a number. All right, so I'd like you to try one more quadratic, plain old-fashioned, already been factored, equals 1. And why can't you just slap this thing right into the quadratic formula? Because it's not set equal to 0 yet. Okay, go ahead. Solve that one. And if it doesn't factor, use quadratic formula. All right, so here's what you should have been thinking. Got to multiply it out. X squared outside inside makes plus x, and then negative 3 times 4 makes negative 12 equals 1. Then I move the 1 over to the other side by subtracting 1 from both sides. So really this becomes negative 13. I'm thinking there's probably not much hope that that thing's going to factor. 13 times 1 is the only way to make a 13, so the middle term, yeah, I'm not going to be able to make that factor. So I go right to x equals negative b, negative 1, plus or minus the square root of b squared, which is 1, minus 4 times a times c, which is 4 times 1, which I really don't need to do, times negative 13, all over 2a. 2 times 1 is 2. There we go, other than my negative 13 looking funky. That's what you should have had. And I actually would expect you to be able to multiply 4 times 13 in your head. 52. All right, and then I have 1 plus 52 because there was 2 negatives in there. So that's going to make 53. So negative 1 plus or minus the square root of 53 all over 2. Do you notice there's 2 answers there? Notice it's plus and minus. You're going to do once with plus and once with minus. So, all right. A lot of times there are 2 answers to quadratics. It makes sense. Now, sometimes the answers, there's 2 of the same answer for a quadratic. But all right, now what would this problem have looked like in the very first place? This problem would have probably looked like this before I did the substitution. It would have looked like log of x squared plus log of x minus 13 equals 0, or something like that. All right. So what you have to look for is, oh, there's something squared. There's something that's not squared, and there's a number. All right. Let's actually start some of our homework together here, and we'll practice. Wait, one more kind that's before we get to the homework. Okay, I don't know what you're talking about. Raise your hand before you start talking. What? Yes? Okay, you don't. You get the red one to look like the black one by making a substitution, and you say, I'm going to let, wherever I see log x, I'm going to let that be an x. So you say, let log x be x, and then you solve it like a normal problem all the way down, get the answers, but then log x is equal to this is just a big number. It's an ugly number, but it's a big number. All right, I can tell you need to do one all the way from start to finish, and that's what we're about to do. All right, except I want to actually do one of your homework problems so that you don't feel like we're wasting your time. I have one more, though, that I got to show you before we do that. Do you remember this pattern? What is that equal to? You don't remember this pattern, do you? If I had 8 log base 8 of 23, the answer is what? 23. So what's all of this? It's just x. Okay? So don't forget that pattern. You're going to see that one again. So if it said x equals 5, then this would all be x equals 5. I'm done. The answer is x equals 5. I know the answer is 5. Because all of this is just x, because these two are the same. So what if I said 3 log base 3x plus 5 log base 5 of 5 is equal to 12. Should we be able to solve that? What's this part? X. What's that part? 5. X plus 5 is equal to 12. X must be 7. Get that? All right. Now let's do one of those substitution kind of problems, except a little weirder. Let's go with 5. Wait a minute, let me think. There we go. E to the 3x. Nope, 2. It has to be 2, because I got to have something squared, something not squared. Okay, plus 2e to the x plus 7 equals 0. Do you see how I've got something squared, something not squared, and then a number? And therefore this is a quadratic. So what should I do? I should let something be x. Let what? Close. Let something equal x. Let what? There you go, e to the x equal x. So wherever I see an e to the x, I'm going to put an x, like I see one right there. So I'm going to erase it and put an x. I see another e to the x right here. Can I just take it out of there? Kind of. Watch what I'm going to do. I'm going to rewrite this as e to the x to the second. Do you get how that's the exact same thing as this? And why is it good? Because I take out the e to the x and I put in an x. So now I have 5x squared plus 2x plus 7 equals 0. Is that kind of your classic quadratic? Yes, it is. To do a substitution, you can let log x be x, you can let e to the x be x. All right, we're going to have problems just like that. Let's do one now off your worksheet. So here comes your worksheet, pausing for log x plus 5. All right. This first one, think about this. You got something that's plus that can be put together. Exactly. So it's going to turn into log x minus 2 x plus 5 equals, this one's got that pesky 2 in front. Could I fix that so that I can just cancel my logs off really easy in a second? Yes, put that 2 up as a power here like that. And now I'll have log 3 squared, which is the same as 9. Now, who knows what to do next? I just said it 2 seconds ago. Nope, it's not a substitution one. I don't need to. Cancel, cancel. Now it's, technically that isn't a cancel. Technically it's this is equal to that. But either way, it works like canceling. X minus 2 times x plus 5 equals 9. And I showed you how to solve those. Multiply them out. You got to get the 9 moved over. You can't put this into the quadratic formula until that 9's come over to this side. So, I like that saying. All right. So, your next step is multiply it all out, move the 9 over. Yes, I don't think this one factors, so you're going to have to stick it in the quadratic formula. All right. Let's move on to a different one. Number 1 will be pretty easy for you, really, compared to the others. Let's look at number 2. That's a lot like that one where I did a substitution. Let's see if you are smart enough to figure out what you're supposed to let x equal. It's 2e to the 2x plus 5e to the x. Sorry, 5e. Wrote the e wrong. E to the x minus 3 equals 0. So, let x equal what? Yes. And so whenever I see this, I should put in an x and an x. And then hopefully it'll factor. But if it won't, then you have to use quadratic formula. So let's just kind of work through this one a little more thoroughly. So this has now become e x squared. Remember, this is still a squared. Plus 5x minus 3 equals 0. I'm really hoping it factors. Does it? Yeah. Excellent. 2x and x. And then can you help me finish it? There's got to be a plus and a minus. Who's got it? Minus 1 plus 3. I'm checking you now. Outside is 6x. Inside's minus an x. Makes total of 5x. Yay, you're right. So, there we go. I made the middle term work out. So now, it's not as simple as just get the answer. Now I've got to do I got to pay the price for having made it easier earlier. Remember how I let x equal e to the x? Then I got to go back and put in the e to the x back into the equation. So I would personally wait till I got it solved, though. I would have 2x minus 1 equals 0 solved first. So I'm going to add 1 to both sides. 2x equals 1 and x equals 1/2. But now it's not x anymore. What is it? I think it was just let e to the x equal x. So it's, no, I moved the 2 over and it's 1/2 now. So I take my x equals 1/2. Here, I skipped a step. I shouldn't do that. There, I solved it. Now I got to substitute. E to the x is the same as x. Is that solved all the way? Is x alone yet? No. Anytime x is in the exponent, that's what logs are for. So, final step to actually solve this all the way. Log base E of 1/2 equals x. And that is just a number, and do you know what it is? No. And that's why you can leave it that way, because the calculator is the only way you'd know what ln of 1/2 is. Very good. So you're going to have x plus 3 has to equal 0. So x has to equal -3. And then you're saying e to the x can't be a negative number, can it? So right there, you should know it's not going to work. Otherwise, if you wanted to, you can go one more step. ln of -3 equals x, and that's not allowed either because you can't have a negative in the argument. So, yeah. All right, sounds like lunchtime to me.